Hello dear all beautiful students, welcome all to our today's session after a long time of Eid vacation. I hope so you have passed a nice Eid vacation with your family. Then again we are coming here for joining a new session, starting the new time, though the exam upcoming test is very near to you, but hope so you are getting well and will be connected before the test. The class is going on. Very first time I want to say that we already started the chapter 11 and we already understood the many of the important topics from chapter 11, and today we will go through a new discussion, that is total internal reflection. So today we will go through the total internal reflection. Total internal reflection. Total internal reflection. It is very important thing, though in very first time when we started the chapter 11, we know about the reflection and refraction, and we have that idea when any light ray come to from one medium to another medium, but in between them a reflected surface. When light fall on there and come back to the same medium is the reflection. When just go through that the different medium and make it bend of its rays, so that time so you can say that is the refraction. So total internal reflection, if we want to know from there, so we have to know important thing, that is refraction. How can it be a reflection, and there also be a critical angle, and we have to know many of the important things from there. So very first time I want to say you, please try to understand this figure. So I take a medium, okay, it is a water medium. We already gotten that one, and just you will use the pencil compass pencil for drawing the figure all time, because if we draw the figure with pen, that will be not much impressive, and it is not the rules of drawing the figure. So drawing figure with the pencil is mandatory, okay. Yes, so suppose there is the water. We have taken the water from there, water medium, and this one is the air, okay, air, and this one is the water. So very first time we can say here that this is the denser medium, water is the denser medium, and air is the rarer medium. Since we know about that points, that which one is the denser medium and which one is the rarer medium, that is the question asking parts of them. So this one is the water medium, that means the denser medium, and another one is the air or rarer medium. Yes, what we want to say here, suppose we know that in very previous types of explanation, we know light come from one medium to another medium. Since if we want to understood about total internal reflection, that times it is needed to very importantly keep it in mind, that is always light come from denser medium to rarer medium. It is a condition, very important condition for total internal reflection. So suppose we take this one ray come from denser medium, and go to the rarer medium, okay. So light ray come from here and goes there, okay. So look at here, if it is the perpendicular line, we can count it there. With them the angle of incidence is going on there, and angle of refraction or refracted angle you can say. So what is the reason of that matters? We know the condition of the refraction, law of refraction. When we understood that times, we know about when light comes from denser medium to rarer medium, denser to rarer medium, that times the refracted angle will be greater than the incident angle or angle of incidence. Here always this was the condition, this was the law of refraction. You can remember this one. If you forgot this one, please after the class check back your previous lecture, you will get that one. Angle of incidence when denser medium to rarer, denser medium to rarer medium, light comes from denser medium to rarer medium, on that time angle of incidence is less than the angle of refraction, or refracted angle is greater than angle of incidence. Okay, it was the condition we understood in previous time. So here we see R1 or R is greater than I. Again, if we go through another rays similar times, we will see another ray come from this way, and what happened there we will try to understand. Suppose it was is the R1, we take this one is the R2. Suppose this one is the I1, we take the I2. This one is the I2. What happened? Look at here. When angle of incidence, look at here, is gone again from denser medium to rarer medium, light ray from here, and this one is the refracted surface as like as then bend to the another medium, and I1 is less than the R1, I2 is also less than the R2. But what is happening here? Very important point is those incident angle create the 90 degree. Look at here, this one is the 90 degree almost. If it is the perpendicular line with the surface, it produces the 90 degree angle. Okay, but because of this angle, and always the law of refraction say that when light comes from denser medium to rarer medium, it just go far from the perpendicular line. So I2 can produce 90 degree in the refracted angle. Okay, but here not 90 degree making, but there 90 degrees making. So this angle is called theta C. This is the theta C. That means this is a critical angle. Okay, theta C is called critical angle. Many of the students can did mistake here for understanding the critical angle. I will make you understand again critical angle. So I didn't write the total internal refraction definition. First time I want to say the critical angle. Critical angle. We need to know about the critical angle. Critical angle is very important thing, because it is asking for JC exam several times. What do you understand by critical angle? What is the value of the critical angle? It is also I will discuss you. Look at here. Yes, many of you are joining there. I have seen. Very good to see. And yes, all of you after a long time I have seen that you were joining and say salam. Sohail, Rozi Sultana, alaikum salam. Rahma, alaikum salam. Ayman Al Tahmid, alaikum salam. Yes, Nahar Kaji Kamrun, alaikum salam. Adrito, alaikum salam. So very important thing, very important topics we discuss here. Very important. Look at here. Try to understand what we are going through. First time, light, very simply, denser to rarer medium. Light will go from denser to rarer medium. Okay, light from denser to rarer medium. So on that time, law of refraction say that refracted angle will be greater than the incident angle, and with the perpendicular line it can go far and far. Okay, so again another incident angle can produce another refracted angle, but that times also again R2 will be greater than the I2, but from this incident angle can produce the 90 degree on the refracted angle, 90 degree, so that this incident angle is called the critical angle. Okay, when light definition, if we try to understand about critical angle, when light come from denser to rarer medium, denser to rarer medium, it produce 90-degree angle in the refracted angle, so that incident angle can produce 90-degree angle. That refracted angle can produce 90-degree angle in the time of refraction called critical angle. Look at here I2 is the critical, I2 is called the critical angle. It is denoted as theta c. This is called theta c. Yes, look at here. I write in explanation, that means write in the long form, so that why it is write in long form for your better understanding. And look at here, I write there, when light comes from denser to rarer medium, it produces 90-degree angle in the refracted angle, so that the incident angle can produce 90-degree angle in the time of refraction called critical angle. Here I2 is the critical angle. Many of the students did mistake after understanding also these topics. Then also why they did mistake here, because they think that this 90-degree angle may be the critical angle. No, those incident angle produce the 90-degree angle in the refraction. Those incident angle can produce the 90-degree angle in the refraction. That times this angle, since I1 cannot produce, I1 produce the R1 will be greater than the I1. But when I2 can produce the 90-degree in the refraction, so here I2 is called the critical angle, because this angle produce the 90-degree in the refraction. So I2 is the critical angle, and it denoted as the theta c. So critical angle can denote it as the theta c. Keep it in mind. Okay. And in the JSC exam, it is asking one question, that is, what is the value of the critical angle? What is the value of the critical angle? Those students who are joining there, can you write the comment here? What is the value of the critical angle? Can you know that the points that what is the critical angle? Okay, so those incident angle can produce the 90-degree angle in the refraction, that is called critical angle. So I ask you, what is the value of critical angle? It is a JSC question. Okay, so you need to know about the value of critical angle. Many of the students did mistake in previous time, in previous year, and all time. Okay, so don't do mistake for getting that. There will be option, the 90-degree, 85-degree, 45-degree, or below 90-degree, or 120-degree, like that. Always think about that. This one critical angle, the value of critical angle, always less than 90-degree. Less than 90-degree value of critical angle, because many of the students did mistake in previous time. They think that 90-degree is the value of the, this is not the critical angle. Critical angle is this one is not 90-degree. This one is not 90-degree. This one is the below of 90-degree. Okay, so I think you understand this one, the critical angle. Now another way, if we see another incident ray come from there, and then it will be just bend and bend, of course will be there. So this one is also, so here suppose there this one, it was the I3, this one, and this one will be the R3. Okay, again when we see another incident ray or incident angle can produce or can go through from the denser medium like water medium, and look at here, there is no another way, they can come back to the same medium, they can come back to the same medium. Okay, so in this way, suppose it is the I3 and this one is the R3. Of course, always R1 is greater than I1, R2 is greater than I2, R3 is greater than I3 according to the law of refraction, we know. And what happened there, again when it produced critical angle, when produced the 90 degree, then after another incident ray when come back there from the denser medium, it fall down to the refracted surface and it come back to the same medium. Look at here, this one from water, this one come back to the same medium, and in the same medium when it fall down, any light ray can fall down on the refracted surface. Okay, fall to the refracted and come back to the similar surface, that is called, look at here, total internal reflection. Already refraction is going on there, not reflection. I1 refracted, I2 refracted, but I3 come back to the same medium. This is called the total internal refraction. This is called total internal refraction. When light ray come from the same medium and come back to the same medium after getting the refracted surface, that times it is called total internal reflection. I think it is understandable, you can easily understand. I will review one time again. We know about the law of refraction. I will give you a SW task from there. If we go through understanding about that points, the very first time we know about the one is the water medium, another is the air medium, this is the denser medium, this one is the rarer medium. So what we see here, we see light come from the denser medium to rarer medium. So on that time I1, if it is take the I1 is less than the R1 because law of refraction. Again another ray come back to there, but they produce the 90 degree in the refracted angle, that is called the critical angle. We know those angle from the incident angle create the 90 degree in the refracted angle is called the critical angle. We already write the definition, and the value of the critical angle is less than 90 degree, and theta c is the denoted part of there. And another angle I3, incident angle I3, and fall down there and it come back to the same medium after the reflected surface. So this is called total internal reflection. So what is your work? Your work is write the definition. I make you understand the total internal reflection. When come back from water medium, when light ray come back there, fall onto the reflected surface and come back to the similar medium is called total internal reflection. So it is your work for writing the definition and explain the figure total internal reflection, TIR, total internal reflection. I write short form, you can write the long form. So you can explain this figure all time. Must there will be I1, I2, I3 mentioning R1, R2, R3. What I told you, the story like a story. So you will write on that way. Okay, on that way the explanation. Okay, my dear student, this is your SW task. There is the two condition of the total internal reflection. What I have told, if we take suppose DS, your explanation can be the different way also. I1, I2, you can take suppose this one is the A, it is the O, it is the B, you can write the C, D in your explanation in this way. It is the E, it is the F. So you can write according to this format. This one, suppose it is the N. Your explanation in any way, suppose I give it this one. So here incident angle AON and refracted angle BON prime. So that I1 is the AON and R1 is the BON prime. It will be greater. Your explanation you can go through on that way. CON is the I2 and here DON prime is the R2. You can write in this way also according to the geometrical structure when we explain that one. And two condition always there. Two condition of total internal reflection. Two condition. Condition number one. Condition number one, always denser medium to rarer medium. Total internal reflection TIR, always it is of course always done denser to rarer. That means light always come from denser to rarer. Rarer to denser, if it is going on there, that will also be done, but it is not actually properly done there. So the main condition TIR, if it is, we explain denser to rarer medium. And look at here the number 2 short form, it is given in your book, you can see from there. Incident angle in the denser medium greater than the critical angle pair of chosen medium. Look at here, it is another important point. Incident angle, suppose I will be greater, okay, critical angle in this time. Look at here, sir, why is I is actually, I write short form. Incident angle will be greater than the critical angle of the chosen medium. This is the critical angle I2. I make it sure there I2 is the critical angle because I2 can produce in the refraction 90 degree. Okay, so I2 is the critical angle, but another I3 is also there for total internal reflection. But total internal reflection, this is the total internal incident angle. Total incident angle is this one. Because of this I3, it produces R3 and total internal reflection there. So in case of total internal reflection, incident angle of course will be greater than the QC, critical angle QC, of course QC, theta C. So this theta C, so that I make you understand the critical angle theta C is this one, but when this one cannot produce the total internal reflection, another incident angle can produce the similar medium, so it is the incident angle, refracted angle, and total internal reflection is done there. So this incident angle is greater than the critical angle. So this is the second condition. On this way, we learn about very important topics. Total internal reflection, I gave you SW, explain the figure of total internal reflection. Today, that's all about there. So you will try to understand everything, and if you don't understand, see the video again from the first time. If anyone not understand, I hope so you will understand once again. Very important topics we learned today. We will go through the new topics in the next time. Till then, everyone, stay safe, stay sound. Allah Hafiz.